Hello, my name is Kuncheng. This is my midterm presentation for course system engineering. My project topic is solar system. Let's see the background. First, let me introduce two different graphs. The first one is the energy reserved for fossil fuels right now. The green is coal, the red is gas, and the blue is oil. So we can easily to see these three main fossil fuel resources will run out in few decades later. And another graph is US energy consumption by energy source. So the three main source is the fossil fuels and it's account to around 70%, and the renewable energy just account to 11%. So it is imperative to develop renewable energy currently. My project purpose is a California building system. In California, solar PV systems are increasingly becoming a first choice for companies and institutions. In California, it is hard to see the raining day and almost is the Sunday. With the reduction of the fuel resources and increase of the price of electricity, many companies or organizations trying to use the new energy sources. So the graph is an example in California with a solar system. Because the price of electricity is expensive if there is a big consumption for a big building, you can see a statistic graph for the price of electricity. The price of electricity is increased year by years. You can see the graph, and therefore, an economic system of electricity is essential for any big-scale company or organization in California. Because to support our life, if the cost is too high, and also will consume a lot of fossil fuel, that's bad. So but in California, there are enough sunlight to provide enough solar energy. So why not we choose a new system using solar energy? According to the simple analysis, my design solar system is a need-driven system because my design is used to a commercial field, and because the solar system is used to many fields currently. The technology is more mature right now, so there is no very big and new technology need to develop. So my system is a need driven system. So according to above details, we need to know the objective of my system. The basic requirement of new system is should be economical and durable. This is the main purpose for my system, because this is the purpose is to save money and save the resource. Let's see the objective tree I created. First one, the system need to durable. Because this is a long period project, we cannot get money directly if the system just established. We need to use a long time to save money. So my system should be rigid and returnable. Another important factor is efficient, because in order to save money and to reduce the power loss. So my system should be efficient and can make perfect power conversion. Another objective is the all performance need to be monitored because this is power system is dangerous. Everything working high voltage situation. So also there is a big battery. So if there's some accident, maybe it would be cause a big problem. So everything need to be monitored. Another one is interface. It can have a feedback and interpretable. The last one is my system should be smart. We cannot make a person to do the any instruction for my system. So it should be work automatically. According to the objective, we can make the system to become several functional subsystems. The first one is the source subsystence. This one is combined with solar PV panels, which is the most popular component to collect the sunlight, the solar energy from the sun. So this one should be low cost and high efficiency. So this is the good choice, I think. Another one is the storage subsystem. This subsystem is designed to cope with some emergency or some special situation, like a lot of rainy days. There is no enough solar energy, so the storage subsystem can store the solar energy from the actual solar energy before, and it can support to the building load and make the building work normally several days. So this is the storage subsystem. Another two important subsystem is protectional one and control one. These two subsystems can ensure the safe of the new system. The protection subsystem can easy to understand. This one is an example for battery management system. This system is used to monitor the battery of the health of the battery, because the big battery bank is very dangerous. So this one can monitor the situation of them, and if there's some abnormal, this one can make the battery shut down. And also we have another protectional component. This is just an example. And the FPGA board is used to control the whole system. The FPGA board can connect to the computer and also can connect to the battery converter, anything, and it can deal with the data from the converter from the panel and make them go to computer and do some instruction automatically, and we can use software to code it to do something. Next, this power conversion subsystem is the key portion for the new systems, because we cannot just make solar energy goes to building load directly. We have to make the solar energy to electricity with normal voltage, like AC current with 110 volts. So we have to use converters and inverter. This one is an example for DC by the direction of buck boost converter. This is designed to change the direction of the current. If the solar PV change the solar energy to electricity, this one can connect to the controller and change the current flow to battery or to building load or do something. And also this one can change the voltage of the electricity. This is important. And this one is an example of inverter because building load need AC current. So, but the solar energy just can translate to the DC one. So this one can change DC current to AC current. Let's see the initial architecture. This graph I created can show the whole process of my system work. Like you see the sun, and the sun provide the energy to the PV panel. The panel get the energy, and they connect to the. You can see the three green blocks. This may be a sensors. The sensors can get the data from the PV panels, and the building load measurement can get the data from the building load, and the battery measurement can get data from the battery bank. It's the sensors collect the data and make the data goes to controller. The controller connect to the computer, and the computer can do some response and make some instruction to the controller. The controller can give the instruction to the converter. The PV panel also can translate the solar energy to the electricity. The electricity goes to the converter, and the converter has the instruction from the controller, and the current flow know where they need to go. If the controller let the electricity go to the building load, and the converter can make the electricity to get a normal voltage and goes to the DC to AC converter and make it to AC current and goes to building load. And another way is the controller also can make the electricity goes to the battery bank. If their actual energy, or if the building load stop to work, the energy from the sun can go to the battery bank. And if there's some abnormal happen, the building load measurement can get the data and goes to the controller, and the computer will respond. Maybe the converter will be shut down, and the panels will be shut down, and the battery bank can supply the energy to the building load. That's that. This is my process of the system work. According to the above introduction, my system should be work, but we also need to consider the main risks. The main risks is safety work and the complex process of the test. You know this is a power system. The power system always working high voltage, so that is very dangerous. So we have to, because the dangerous situation, we have to do a lot of tests for the software and the hardware. Every component, every subsystem, we need to test to ensure the safe. Because if there's some situation, maybe cause a very big problem. And another risk is accident of the weather. This one maybe can ignore, but you know, in California there is occasionally earthquake and rainstorm, so we need to consider that and do the trade-off for the cost, efficiency, and to do something. According to the risks, requirements of efficiency and cost. The choice of materials and components should be do some trade-off. According to the research of the market and the analysis of trade-off, the efficiency should be achieved 80%, which is a good percent, but will be not cost a lot. The payback period cannot exceed 5 years. Although the system is a long-term system, but 5 years is enough long. So we need to get paid back after 5 years, basically. And the predicted duration is 20 years. So because we have to cost like maintenance fee, and if some component broken we need to repair, so we have to consider them together and to do some decisions for the components and the materials. In conclusion, the system is feasible. Absolutely, you can see the advantage, like save money, and we can reserve the fossil fuels, can protect the environment. So if there is no big accident, I think my system is feasible perfectly. Thanks for your attention. That's my presentation. Thanks. That's it.